So the goal of our project was to bridge heritage and innovation. So for the forging aspect of our project, we were really interested in the Viking Seax knife, which is the historical Viking style blade. To bridge towards innovation, we also wanted to learn more about additive manufacturing techniques. So for our handle, we designed a 3D printed lattice composite structure that we're then able to fuse and connect towards our handle, bridging both heritage from the forging techniques and the metallurgy to sort of new polymer additive manufacturing techniques. We chose an alloy that was barium S53, which is an alloy that was developed by Questech, which has a connection to Northwestern University. It was founded by a couple of alums. And we also chose it since we wanted to focus on a precipitate hardened steel, because we wanted to learn more about precipitate hardening. It sort of relates to a lot of the coursework that we're doing within our curriculum.
In order to start actually making our blade, our first step was to create a model of the blade in CAD and then to print that out as a base for what we actually wanted the blade to look like when we forged it.
When we first arrived in the shop, we made sure to go over important safety measures such as wearing safety glasses at all times and hearing protection when using loud machinery such as the power hammer. We also made sure to generally wear cotton fiber clothing and avoid synthetic fibers. For the blade making process itself, we started by sectioning off our material into the pieces that we wanted to use to shape our blade. We also started with a smaller test piece to get a general sense of forgeability of the material.
After making the test piece, we put the actual piece into the furnace and then put a notch into that after we took it out of the furnace using a guillotine tool in order to create a tang that we could draw out using a power hammer. But first we needed to hammer out the scales to make sure that it's even, and then we put it into the power hammer. After sufficiently drawing out the tang, we next needed to draw out the blade itself. So we used a very similar process in order to hammer out the blade, in order to draw it out and make it more into the shape that we were looking for during the CAD.
We finished off by doing some final shaping and working with the hammer until we were happy with the shape of our blade. Lastly, we finished by quenching in order to lock in the microstructure. And then we did some grinding to add in the edge. And here is a side-by-side comparison with our prototype. We took our blade back to the lab in order to heat treat it to obtain the desired properties and further develop the microstructure. Lastly, we did some grinding to remove the oxidized layer and add the finishing touches to our blade.
To create the handle of the blade, we started with an FCC lattice that we modeled in CAD. So we printed this out using purple resin for Northwestern colors to serve as the basis for the handle. And then we created a TMS mold in order to fill with epoxy, in order to create a full handle that you can hold and that has that transparent look to it. Then we created two pieces of this, as well as a middle piece, and applied some super glue in order to put some of these pieces together.
Next, we applied a layer of JB Weld in order to attach the tang to the handle. We spread on a final coat in order to attach the last part of the handle. And then we applied a layer of nail polish to give it a shiny finish.
Baby, what have I done? Get your sexy on. Get your sexy on.